Okay, 2.4.4, we need to prove that AB is -4. If you go to page 31, you'll find out that if you do s to the first plus s to the second plus s to the third, etc., all the way to s to the 16th, you'll get -1. So we use that fact to simplify this. Also, we use distribution, and that's about it. So first thing we do is we look up the a value that is on page 31, and that's on page 31, so is the b value. So we multiply these together, and we get s multiplied by all this. So this is b. Okay, so s times s to the third, s times s to the 10th, s times s to the 5th, etc. So that is all represented right here using distribution. Okay, so then we do it another time. So we're distributing s to the 9th to all this, and that's all represented here. And then we continue that process until we're done with the last one. So that means we end up with what we see here, right here. All that to here. So at this point, we can just go ahead and add these all together. So 6 plus 2, for example, is 8. And when we add 3 plus 1, that's represented right here as 4. So right here, this is the simplified exponents. Then notice that we get 4. This is the simplified exponents. Okay, so now notice that we can get 4 of each. So check it out. So here's s to the 15th, and it says that there's 4 of them, right? Right here it says there's 4 of them. So let's go ahead and look. Is there 4 of them? Here's one. Here's one. Here's one. And sure enough, we get 4 of them. So then that simplifies down to this here, right there. Okay, so we get 4 of each. And then, so let's factor out that 4. Now we got this right here. And that goes back to what we were talking about before. S to the first plus s to the second plus s to the third, etc., all the way to s to the 16th is going to be -1. So all this here, not the 4, but all that there is going to be -1. So 4 times -1, -4.